Q7094. When landing a gyroplane in crosswind conditions, proper technique requires that the A. Longitudinal axis be parallel to the runway. B. Direction of motion and heading coincide with runway direction. C. Lateral axis of the gyroplane be parallel to the gyroplane's direction of motion. The correct answer is B. When landing a gyroplane in crosswind conditions, it is important to align the direction of motion and heading with the runway direction. The proper technique for landing in crosswind conditions. Crosswind refers to a wind blowing perpendicular to the runway, which can affect the gyroplane's direction and stability during landing. Proper technique involves adjusting the gyroplane's heading to compensate for the crosswind and maintain control throughout the landing process. By aligning the direction of motion and heading with the runway direction, the pilot minimizes the sideways drift caused by the crosswind and ensures a safer and more controlled landing. This technique allows the gyroplane to maintain its intended path along the runway and reduces the risk of drifting off course. To achieve this, the pilot needs to apply appropriate control inputs, such as using the rudder pedals to counteract the crosswind and keep the gyroplane aligned with the runway. By using the rudder to maintain heading, the pilot can counteract the forces exerted by the crosswind and maintain control over the gyroplane's direction. Maintaining the direction of motion and heading in line with the runway direction also facilitates a smoother touchdown and reduces the risk of side loads on the landing gear. It allows the gyroplane to touch down with the longitudinal axis aligned with the runway, minimizing the potential for lateral forces that could lead to instability or loss of control. 7176. The reason for retaining water ballast while thermals are strong and dumping the water when thermals weaken is to A. Decrease forward speed. B. Increase forward speed. C. Decrease the rate of descent. The correct answer is B. When flying in a glider or sailplane, pilots often use water ballast to increase the aircraft's weight and optimize its performance during different flight conditions, including flying in thermals. Thermals are columns of rising air that glider pilots utilize to gain altitude. When thermals are strong, the glider can climb rapidly, benefiting from the upward lift generated by the thermal. However, as the thermal weakens, the rate of climb decreases, and the glider's performance may be affected. Retaining water ballast while thermals are strong helps to increase the glider's forward speed. By adding weight to the glider, the pilot can adjust its balance and trim for higher speeds. This increased forward speed allows the glider to cover more ground during each thermal climb, maximizing the distance covered and improving overall efficiency. The added weight from the retained water ballast also helps to stabilize the glider's flight and counteract the effects of turbulence. It provides a smoother and more controlled flight experience, allowing the pilot to better exploit the rising air currents within the thermal. However, as thermals weaken, the glider's rate of climb decreases, and maintaining the additional weight from water ballast becomes less advantageous. To adapt to the changing conditions, pilots often choose to dump or release the water ballast. This reduces the glider's weight, making it more agile and responsive. By dumping the water ballast when thermals weaken, the glider's forward speed can increase even further. The reduced weight allows the glider to accelerate and fly at higher speeds, optimizing its performance for the prevailing conditions. 6713. For a winch tow, which is an advantage of the CG hook over the nose hook. A. A shallower climb can be used during launch. B. Glider is less likely to pitch up if the towline breaks. C. Likelihood of applying too much backstick pressure is reduced. The correct answer is B. During a winch tow, the towline connects the glider to a ground-based winch or towing vehicle, providing the initial force to launch the glider into the air. In the event of a towline break, the behavior of the glider can be affected depending on the type of tow hook used. The CG hook, also known as a center of gravity hook, is positioned closer to the center of gravity of the glider, while the nose hook is located near the nose of the aircraft. The position of the tow hook affects the glider's aerodynamic characteristics and its response to an unexpected release of the towline. The glider is less likely to pitch up if the towline breaks when using a CG hook. Here's the reasoning behind it. 1. Center of gravity, CG, stability. The CG hook is positioned closer to the glider's center of gravity, which is the point where the aircraft's weight is concentrated. This location provides better pitch stability and reduces the likelihood of abrupt pitch changes. 2. Aerodynamic balance. With a CG hook, the release of the towline creates a more balanced distribution of aerodynamic forces around the center of gravity. This balanced aerodynamic configuration helps prevent the glider from pitching up excessively when the towline suddenly detaches. 3. Pitch control. The glider's response to a towline break largely depends on its inherent stability and the pilot's ability to control the aircraft. With a CG hook, the glider is less prone to sudden and excessive pitching, making it easier for the pilot to maintain control and prevent a dangerous pitch-up situation. By reducing the likelihood of a pitch-up motion, the CG hook provides an advantage in terms of safety during winch tow operations. It allows the pilot to better manage the glider's response in case of a towline break, reducing the risk of a loss of control or a sudden and potentially dangerous pitch-up. 6714, which is true regarding glider tow hooks. A. Use of a CG hook for Aerotows would cause a glider to pitch up. B. Use of a CG hook for winch tows would cause a glider to pitch up. C. Use of a nose hitch for Aerotows increases the climb attitude and release altitude. The correct answer is A. Glider tow hooks are devices used to connect a glider to a tow aircraft or ground-based winch for launching. The position and design of the tow hook can have an impact on the glider's aerodynamic behavior during the tow. Here's the reasoning behind it. Center of gravity, CG, effects. The CG hook, also known as a center of gravity hook, is positioned closer to the glider's center of gravity. The center of gravity is the point where the aircraft's weight is concentrated. When a tow force is applied to the CG hook during an aerotow, it creates a pitching moment around the center of gravity. Pitch-up tendency. The placement of the tow force at or near the center of gravity can cause the glider to experience a pitch-up moment during the tow. This means that the glider's nose has a tendency to rotate upward, increasing the angle of attack and potentially leading to an unstable or uncomfortable flight condition. Pilot intervention. To counteract the pitch-up tendency caused by the CG hook during an aerotow, the pilot may need to apply forward stick pressure or make adjustments to the glider's pitch attitude. The pilot's input helps maintain a stable flight and prevent excessive nose-up pitching. It's important to note that the specific aerodynamic characteristics and behavior of a glider during a tow can vary based on its design, weight distribution, and other factors. The use of a CG hook for aerotows generally requires pilots to be aware of the potential for pitch-up tendencies and be prepared to take appropriate corrective action. 6719. What would be the approximate tensile strength of a rope with a 1,000-pound tensile strength if a knot develops in it? A. 500 pounds. B. 800 pounds. C. 1,000 pounds. The correct answer is A. When a knot develops in a rope, it creates a point of concentration where the rope's fibers are bent, twisted, or compressed. This can weaken the rope and reduce its overall tensile strength. In general, when a knot is tied in a rope, the tensile strength of the rope is significantly reduced. The exact reduction in strength can vary depending on factors such as the type of knot, the material of the rope, and the quality of the knot tying. However, as a rough estimate, it is often assumed that a knot in a rope can reduce its tensile strength by approximately 50%. This means that the strength of the rope with a knot in it would be roughly half of its original tensile strength. In this case, if the rope has a 1,000-pound tensile strength and a knot develops in it, the approximate tensile strength of the rope with the knot would be around 500 pounds. This estimation is based on the assumption that the knot reduces the rope's strength by approximately 50%.